So today we'll be building a web application with LangChain and Streamlit, where we'll implement the smart study buddy we created in the previous video. So this is what the application will look like. We let the user upload a file with all their study material, and then with the help of AI and LangChain, the large language model will create practice questions based on that study material. So you can see on the screen it already generated 8 practice questions, and then it will let the user choose the questions that the user wants answers to. So I just pick 2 at random, and then it will generate the answers based again on the study material. If you want a bit more in-depth explanation of what's happening or a quick overview, please check the previous video and subscribe to the channel. Leave a comment down below what you would like to see for the next project. And now let's get into the code.
So now for the actual code. I'll start by creating a new file called front.py. This is where we'll create all the Streamlit front end for the LangChain functions. We'll begin with installing all the necessary libraries. So yeah, LangChain, Streamlit, OpenAI, TickToken, ChromaDB, and PyPDF2. I've already installed all of them, so for you it will take a bit longer. And now you can import Streamlit as st. So we can do a simple title with st.title smart study buddy. And in order for us to run the Streamlit file, you can just do Streamlit run front.py. And now you've already created your first Streamlit application. So this just renders the Python file and runs all the code within it. Of course, it's now quite empty, so let's add a bit of functionality to it. We'll add an input widget to get the OpenAI API key with os.environ. So we need to also import OS, OpenAI API key. And we'll use the st.text inputs in order for the user to input their OpenAI API key. So we'll give that a label, API key, which will show on the screen as well. A placeholder, which will just be an example of what a OpenAI API key looks like. And then a key, OpenAI API key. So now go back to your user interface. And as you can see here, the source file changed. So Streamlit always checks if something in the file has changed, and then you can rerun the script. And as you can see, we've added the input widget for OpenAI API key, and the user can just input their API key. Nothing will happen now, because of course we haven't added any functionality yet. Before we do that, we're going to add one more widget, which is the file uploader. So uploaded file is equal to st.fileUploader. We'll give it another label. Upload study material. And we'll specify the type we want, which is a PDF. You can add more type of files, but for this project I only want to use PDFs. You can make it more complicated with CSV files, just regular text, but for now we'll stick to PDFs. Once again, save the file and rerun script, and this will add the upload widget. We'll be uploading our PDF, and that's ready now for you to use in the script later on. So now it's time for us to create some of the LangChain functionality. We'll create a new file for this just to be organized. lc.function.py. And we'll import all the necessary libraries. I will just copy and paste those, just so I don't make any mistakes. And so we'll use a PDF reader from the PyPDF library, the Summarize chain from the LangChain library, token text splitter, a custom class called Documents, and the chat OpenAI module for us to work with the GPT 3.5 Turbo 16K model. And now it's time to create our first function. So we'll have a function to load the data from the PDF. So define load data. This will take one argument as input, which is the uploaded file. And we will set up the PDF reader equals PDF reader. Argument will take the uploaded file. And now we'll extract all the text into a single variable because we want to chunk the text more efficiently. So we'll do it with a simple for loop. So for page in PDF reader dot pages. And we'll add all the text by extracting it. And then we'll return the text. So what this does, it just loops over all the pages that it just extracted with the PDF reader and adds all of that to a single variable. Then we'll make another function, which create a function to split the text into chunks. We'll just call that split text. This will take 3 arguments, so it will take the text, a chunk size, and a chunk overlap. And first you'll need to initialize the text splitter. We do that by splitter equals token text splitter, and this takes 3 arguments. The model name for us, it's GPT 3.5 Turbo 16K. The chunk size is equal to the chunk size, and the chunk overlap is equal to the chunk overlap. So the chunk size variable will tell the token text splitter how large a chunk is allowed to be, and the chunk overlap is the overlap it takes into each individual chunk, so you don't lose any information between chunks. So now we can actually split the text by say text splitter dot split text, and we'll enter the text right there. And we need to do one more step, which is convert the text back to a document class, because that's what LangChain works with best. We'll do that with another simple function. So for t in text chunks, and that will just transform it. So what that does, it will just loop over all the different text chunks and transform them to a document, and it will return those documents. So we'll now implement this into the front end. Let's say if a user uploaded the file, we want to load data from PDF. So text from PDF is equal to load data uploaded file. Of course, we first need to import it from LC functions import load data and the split text. And now we'll split it in 2 different ways. So one, split the text for question generation. So we'll say documents for question gen is equal to split text. Text is equal to the text from the PDF. The chunk size for the question generation part we'll set at 10,000, and the chunk overlap we'll put at 200. We'll also split the text for a question answered. Document answer is equal to split text. Text is equal to PDF. Chunk size will be equal to 1,000 instead of 10,000, and chunk overlap will be equal to 100. So let's save this and this one as well. And then I'll show on screen real quick what the effect is of using different chunk sizes. So we'll just use a Streamlit function called st.write to show some information on the screen. If you go back now, we will rerun it, and this condition will be true. So it will split the text, or it will get the text from the PDF. Then it will split the text in two different ways, and it will show on the screen how many documents there are after splitting the text. So we'll rerun it. Is not defined. Answer. Okay. So with a chunk size of 10,000, we have 2 documents, and with a chunk size of 1,000, we have 11 documents. This will be important because for the question generation part, we will use a summarization chain that will go over all the text. So we want the amount of API calls to be as low as possible. Because otherwise, if you have 20 documents, it will have to go through a summarization chain 20 times. And every time you call the API, you will have a certain amount of costs. And for the question generation part, we will use a vector database and a retrieval question answer chain, but we'll get into that later, which will make more sense then. So it's time to implement some more LangChain functions, because we want to initialize our large language model in 2 different ways as well. So we'll create a function for that. Initialize the large language model. Initialize LLM, which takes in 2 arguments, model and temperature. You could add in a 3rd argument here as well, which would be the OpenAI API key. But because we set it as an environment variable, the program will take it from there automatically. So you won't need it if you do it in another way, just add an additional argument there. So we'll say LLM is equal to chat OpenAI, model is equal to model, and the temperature is equal to the temperature. Very simple function, return LLM. So now it's time to set up our summarization chain, because the standard out-the-box summarization chain in LangChain will summarize the document, but we want it to generate practice questions. So we need to do a bit of custom prompting here. So let's create another file, prompts.py, and I'll just copy and paste my prompts. So first from LangChain, import the prompt template, with which, as the name suggests, you can make prompt templates. And we'll create 2 prompts. Since we're going to use the summarization chain, and specifically the refined summarization chain, we'll need a prompt for the initial chunk that's being fed to the chain, and then also a prompt for refining the questions it generated with the first chunk, which will be the refined template questions. So let's take a quick look. You are an expert in creating practice questions based on study material. Your goal is to prepare a student for their exam. You do this by asking questions about the text below. So this variable will be replaced with the initial chunk that is being fed to the summarization chain. Then we'll give it the final instruction to create questions that will prepare the student for their exam. Make sure not to lose any important information. And then questions. This will be the prompt to the large language model. Now for us, in order to use that prompt, we need to use the prompt template part. And as a template, we set the prompt template questions. And the input variables will be the text, which will be replaced with the initial chunk that we're feeding to the summarization chain. The second prompt is quite similar. There's just one difference, which is here. We have received some practice questions based to a certain extent. And this will be the output of the first run of the summarization chain, because it will generate the questions already from the first chunk. And then it will take the initial information from the second chunk and use that to refine those questions. And if the information in the second chunk is not useful, we tell the model to just return the questions it's already generated. We set up the prompt template with the template as this one. And we need two input variables now. So the generated questions and the text, or the second chunk. So we save that and then we'll import that here. So from prompts, import refine prompt question and prompt questions. And now we can create the function to generate questions. So let's call that generate questions. And it takes in 3 arguments. So the large language model, a chain type, and the documents it needs to work with. So first we need to initialize the question chain. Question chain is equal to load summarize chain. This is just an out-the-box LangChain feature. And this takes the LLM, chain type, a question prompt, which is the prompt we just imported, and the refine prompt. Yeah, which is just called refine prompt is equal to refine prompt questions. You could set an additional argument, which is called verbose. I'll put that to true right now. And this lets the model show its thought process in the terminal. You'll see what that means later. So the question chain is set up. And to generate the questions, you just do question chain.run on the documents. And once it generated those, we just want to return the questions. So now we'll implement this into the front end again. But before we can do this, we need to talk a bit about session states. Since Streamlit always returns or reruns the script when a widget changes, we need to initialize a session state. This is just to store certain kind of information that needs to be stored even when the script is rerun. And we need to initialize empty session states before we can assign certain variables to it. I'll copy this into the project. So if questions is not in the session state, we'll initialize 4 separate question or 4 session states. So 1 for the questions, 1 for a separated list of questions, 1 for the questions the model needs to answer, and a single variable for a submitted part. But you'll understand this later as well. Now we can go back and initialize our large language model. So we'll initialize a model for question generation, which we call LLM question gen is equal to, of course, first import its initialize LLM and generate question. So we'll say initialize LLM. The model name is GPT 3.5 Turbo 16K. And this is the beauty of LangChain. You could just replace this with another model, let's say the GPT-4, GPT-3. You could even work with Anthropic's Claude, Llama, but we won't get into that right now. I'll just use the Turbo 16K because of the larger model size, and it's quite fast, and I like the results of the model. And then we need to set the temperature, and I'll put that at 0.4. Play around with it. I would suggest you keep it between 0 and 1. Closer to 1 means more creative, less predictable. Closer to 0 means less creative, more predictable. 0.4 makes it pretty creative, but it will still stick to the study material. And then we'll also initialize one question answering. So we'll say LLM question answer is equal to initialize LLM model is equal to, again, GPT 3.5 Turbo 16K. And this time we'll set the temperature to 0.1 because we want the model to stick even closer to the study material when answering a question. It shouldn't come up with information on its own, because if you're studying for an exam and you've got specific study material, your teachers want you to probably stick to that material. So that's why we do the 0.1. Try 0.2 or 0.3 if that works better for you. Now we can actually create the questions. So we'll say if st.sessionState questions is equal to empty. So this means no questions have been generated yet. We'll generate the questions. So every time the script reruns, it will check if the questions are already generated. And if that's not the case, it will generate them. We'll use another nice looking Streamlit feature called st.spinner to give our UI a bit of, well, to make it look nice. So we'll just say generating questions st.sessionState questions. And now we'll generate the questions and assign them to the session state, so they will be saved in each run. So what you won't have to generate the questions every time, because this is the most expensive part of the program. And so we'll set the LLM to the LLM question answer, the chain type to be refine. And there are 4 different chain types. I would recommend checking out the LangChain documents to see what's the difference. In our case, refine works best. And then we'll set the documents to be document for question gen. So that's actually it. Now it will already be able to generating questions. And we want to show those questions on the screen because we want the user to pick the questions they like, and then we'll generate answers for them. So if st.sessionState questions is not equal to empty, we'll use st.info to show them on the screen. So st.info questions. You could use st.write, st.code for easy copy pasting, but I like the way this looks. And now let's quickly check again our Streamlit program. So remember, everything is still loaded, so the PDF file is still there. It's already split. It loaded the text. So if we rerun it now, it should generate the questions. It doesn't, because I haven't entered the correct API key. Let me quickly get that one. Never do what I'm doing. Don't share this with anyone. I'll be revoking this key afterward, but always keep it safe and never share this with anyone, because I did that in the previous tutorial and it cost me $100. So please stay safe with your API keys. But as you can see now, it's generating the questions. And what's happening behind is maybe also interesting to show. This is the verbose part we talked about. It will show its thought process. So it says entering new refined documents chain. Then it will take the prompt we created. You are an expert, blah, blah, blah. And it will take all the text from the PDF and put it in there, or at least the text from the first chunk. And then we'll scroll down. It's a long document. It finished the first chain, so it generated the questions on the first chunk. And now it enters the second prompt, which is here. So we have received some practice questions to a certain extent. And these are the questions that it already generated. And then we have the option to refine the existing questions or add new ones. Second chunk is really low, but I just included it to show you how this would work. If you've got a longer document, there will be more info in there. Or if you decrease your chunk size, there will also be more info in here. So given a new text, refine the original questions and show them on the screen. So it generated the questions. As you can see, we've got 10 questions lined up for us to choose from. You could stop here, take these questions and practice yourself with it. We want to go one step further and also generate answers to a couple of questions because you might not like all of them. We will just choose a couple. For us to do this, we need to go back and implement some more functionality here. So let me make this a bit smaller again. So to generate the questions, we'll first need to implement some LangChain functionality. So we'll create a function to create our retrieval question answer chain. We call that create retrieval QA chain. Very creative. This will take the documents and a large language model. So let me quickly tell you what a retrieval question answer chain does. It works with a vector database, which is just a storage of word embeddings. And word embeddings are just numerical representations of text. And we'll use the OpenAI embeddings, which I haven't imported yet. Interestingly enough. Okay, I need to import that. Let me quickly check what that is. So from LangChain.embeddings.openai import OpenAI embeddings. And now we can actually import them. So we've got our embeddings, which are the numerical representation of words. And then we're able to create our vector database. There are a lot of different vector database providers, which could be online, local, serverless. There's a lot of different possibilities. For our purpose, we can use a very simple one called Chroma, which I also still need to import. So from LangChain.vectorstores, import Chroma. Then we've got chroma.from documents. The documents being equal to our documents and the embeddings. So what this function does, it will create a vector database of all the documents that we've provided. Remember, we split this one differently. So there were, I think, 22 documents, which will be embedded as their numerical representations. And these will be stored as vectors. So we've got the embeddings, the vector database, and now we can actually create the retrieval question answer chain. So again, I forgot to import this. So we'll import the RetrievalQA. So from LangChain.chains, import RetrievalQA. This is just also very handy in LangChain. You've got all these different types of chains. So please check out the documentation. There's 20 to 30 different type of chains. So RetrievalQA dot from chain type takes in a couple of arguments, the large language model we've initialized, another type of chain, which is stuff. I won't get into this right now, but you could use a different one, but for our purpose, stuff works fine. And then we'll set the retriever to be the vector database .s retriever. Then we'll return the RetrievalQA chain. So what this retrieval question answer chain does, it will take a question and look for the most similar chunks inside of the vector database. And that's why you have to use word embeddings, because it can compare the different numbers and check which chunks are most relevant to that question. Then it will use those chunks inside of a prompt, which also takes in the initial question, and it will combine it all into one prompt and then answer the question with the large language model. I hope that makes sense. So let me check. Yeah, now we can just implement this into the front end. So once we've shown the questions, we need to split the questions because the question answer chain needs to work with them separately. So we'll take another st.session state equal to questions list. And we'll take our questions and use the Python function .split with the delimiter new line. So what this will do is we'll just loop over the list of, or the string of questions, and every time there's a new line, it will split it and make a list out of it. So now we want the user to be able to select questions for the model to answer, and we'll do that with an st.form. We'll set a key is equal to form. Again, we'll use another session state because we want to keep this, and every time the model will generate an answer, it will rerun the script again. So it needs to save these questions. So we'll say questions to answer is equal to st.multi-select, which is another great Streamlit feature. Label is equal to select questions to answer. And we'll set the options, so the list they can choose from, to be the st.session state questions list. So if I now rerun this, shouldn't regenerate the questions, and we've got a nice error. Let me check. Okay, yeah, this shouldn't, of course, be a string. Apologies for that. This should be just the variable. Let me rerun it, that should fix it. Missing submit button. So we'll add that, because with the form, we want the user to submit it, of course. We'll do that by saying submitted is equal to st.form submit button. And we'll give the button a label, generate answer. Do one more function here, if submitted. We'll set this st.session state submitted, which we initialized earlier, to be true. Now let's rerun it, and now it should work. So now the user is able to choose the question he wants to have answered. If we press generate answer now, nothing will happen. So let's implement that as well. Let me quickly check. Yeah. So we'll say if st.session state submitted, Doing this just means is equal to true with st.spinner generating answers ... Now we'll initialize our retrieval question answer chain. So I'll just name it generate answer chain equal to, first, of course, import. We create retrieval question answer chain here. Go down. Create retrieval question answer chain with the documents to be, let me check documents for question answer, and the large language model to be the LLM for question answer. So now we've got the retrieval question answer chain set up. And now we want to loop through the list of questions and generate an answer to each one. Let's say for question in st.sessionState, questions to answer, we'll generate an answer. So the initialized retrieval question answer chain dot run with the question, and then we'll say st.write question. Let me just use an f string here. Question and st.info answer. Okay, so let's quickly look at this. So what's happening? Let me check. So we've got our question list here, which is just the questions the user chose. Oh no, this question list is just all the questions that the model generated. And then down here, the user will pick certain questions to be answered. Once he presses submit, this will be true. And then it will create a retrieval answer chain with all the documents and create the vector database. And then it will go through all the questions the user selected and generate an answer to that. I hope this makes sense. If not, leave a comment down below with all your questions. I will try to answer everyone. But actually the code is finished now. So if we would rerun it and generate the answer, name CRE is not defined. Of course, save your file, then rerun it. And now it will generate the answer to these two questions. So it will take the first question. So how do large language models become more capable with increasing investment? And we'll look through the vector database, which chunks of information are most relevant to that question. And then it will generate an answer. So large language models become more capable, blah, 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 blah. And it also answered the fifth question. And if you want more answers or more question answered, you can pick another one. What are the 8 potentially surprising claims? So we'll say generate answers again. And it will regenerate answer to all the selected questions. I hope this all made sense. Like I said, if not, I'm here to answer questions as well. I'm kind of an LLM myself. Leave a comment down below. If you like the video, please subscribe and leave a like as well. And leave a comment for suggestions for a future YouTube video. See you in the next one.